a look about the Leetcode-304 range sum query 2D immutable. Given 2D matrix handle the multiple queries of the following types. Calculate the sum of the element of matrix inside the rectangle defined by its upper left corner, row 1 and column 1, and lower right corner, row 2 and the column 2. Implement number matrix class. Number matrix initialize object with integer matrix int sum region, row 1 and column 1. Row 2, column 2, return the sum of the element of the matrix inside the rectangle, defined by its upper left corner, row 1, column 1, and lower right corner, row 2 and column 2. You must design an algorithm where sum range works at O1 complexities. It shows how you behave the constructor. You can see in here. Accept the 2D matrix, right? 2D matrix, and pre-compute some data that the sum region function takes 4 parameters. The solution use a technique called 2D-prefix sum, speed up the sum region query. And write down here, sum region queries. Speed up the sum region query. It compute the pre-compute the sum of subrectangle. Pre-compute the sum of subrectangle. Pre-compute sum of subrectangle. Starting from O to the ending at the ij, right? Ending coordinate. The sum of pre-compute the sum of subrectangle starting from 00 to ij. The pre-computation allows system to answer in constant time. The original the sum region functions use C++ and D++ to match the indexes of the sum in 2D array. The adjustment is needed because sum array is one index both dimension, while the query coordinates A, B, C, D are 0 indexed, right? In other words, sum array has an extra row and extra column to facilitate easier calculation. Therefore, when you query the subrectangle, you have to adjust the bottom right corner coordinate CD to C+1 D+1 to get the sum of the correct subrectangle in one index sum array. Coordinate AB for top right left corner do not need adjustment in the query because when you subtract the value at this coordinate, you are effectively working with one index logics. AB remains the same because it's a right down here, so it's a CD is bottom right, right? We'll write down here. Where is here? Okay, bottom right. And bottom right, C to get the sum of the one and in one indexes, right? Because this is for you to get the is one indexed. And coordinate AB for top corner do not need to adjust because in the query because you subtract the value at this coordinate. You're effectively working with one index logics. So AB remain as it. Well, CD gets increments by 1. Gets increment by 1. Gets increments bottom, right down, bottom left, right? Increase by 1. Y subregion function CD are incremented. The increments ensure the sum of the element is in the correct subtriangle. Returns subtriangles. It returns. So it's a logics, right? Left CD B minus 1, right? B minus 1, B minus 1, then A minus 1, B minus 1. Look at here. A minus 1 D, A minus 1 D, keep minusing. So I will put this one in here. You will see more clearly about the I want to copy. You can see over here can be smaller. CD, what is CD? Equal to minus A G and G1 and G1 and G. Then this is the region of the sum. Okay, so you keep minusing. So you can see over here. So you want to keep minusing 2 and plus the correct one, right? Plus the correct one. So this is to calculate the but this is for the sub one, and but this one is for the L plus upper. This is upper, this is left, right, left, then plus minus what, left, upper. Okay, that's the logics. Okay, let's understand another question.